The cosmic fate of the Milky Way revealed. Hey there, cosmic explorers. Buckle up, because today we're diving into one of the wildest mysteries in the universe: dark energy. Picture this. The universe isn't just growing, it's speeding up, like a car flooring the gas pedal with no brakes in sight. And guess what? This invisible force called dark energy is behind it all, and it's got big plans for our home, the Milky Way. So, what's the fate of our galaxy? Will it get torn apart, swallowed by a black hole, or face something even weirder? Stick with me, because by the end of this video, you'll see the universe in a whole new light. And trust me, it's mind-blowing. Let's jump in. Imagine you're looking up at the night sky, and every star, every galaxy, is racing away from you faster and faster. It's not just moving, it's accelerating, like the universe is in a cosmic hurry to get somewhere. That's what's happening right now. And the culprit? Dark energy. This invisible, mysterious force is pushing everything apart, and it's going to decide what happens to our Milky Way billions of years from now. Will our galaxy survive, or is it doomed to a lonely cosmic end? Let's unravel this mystery together, step by step, with a story that's as epic as the universe itself. Before we dive into the future, let's start with the big picture. The universe is expanding, and it's not slowing down. It's speeding up, and dark energy is the invisible hand pressing the accelerator. But what is dark energy? How does it work? And why should we care about what it's doing to our galaxy? Grab a snack, maybe some cosmic popcorn, because this is going to be a wild ride through space, time, and the fate of everything we know. Let's set the stage. About 100 years ago, a guy named Edwin Hubble, yes, like the telescope, changed everything. He was peering through his telescope, studying distant galaxies, when he noticed something bizarre. The light from those galaxies was redshifted. Now, redshift is like the universe's way of saying, see you later. When light from a galaxy is redshifted, it means that galaxy is moving away from us. And Hubble found that every galaxy was moving away, no matter where he looked. The universe wasn't just sitting still, it was expanding, like a balloon inflating with every second. But here's the kicker. Hubble figured out that the farther a galaxy is from us, the faster it's moving away. This became known as Hubble's law, and it's the cornerstone of modern cosmology. He even came up with a number to measure this expansion, called the Hubble constant. Think of it like the universe's speedometer, telling us how fast everything is zooming apart. Back then, scientists thought, okay, cool, the universe is expanding, but it's probably slowing down, right? Like a ball you throw up in the air. It eventually comes back down. Wrong. Fast forward to the 1990s, and two teams of astronomers dropped a bombshell. They were studying supernovae, exploding stars that act like cosmic lighthouses. By measuring their light, they could figure out how far away these stars were and how fast they were moving. And what they found was jaw-dropping. The universe wasn't slowing down. It was speeding up. The expansion was accelerating, like someone hit the gas pedal on the cosmos. And that's when dark energy entered the scene. So, what is dark energy? Honestly, we don't fully know. It's like the universe's biggest plot twist. Scientists estimate it makes up about 68% of the universe's total energy. That's right. More than 2/3 of everything out there is this mysterious stuff we can't see, touch, or detect directly. It's not like stars, planets, or even dark matter, which we know pulls things together with gravity. Dark energy is the opposite. It's like an anti-gravity force pushing things apart. Picture it as an invisible wind blowing galaxies farther and farther away from each other. Now, I know what you're thinking. If we can't see it, how do we know it's there? Great question. We see its effects. The accelerating expansion is one clue. Another is the cosmic microwave background, or CMB, a snapshot of the universe when it was just a baby about 380,000 years old. The CMB is like the universe's baby picture, showing us the leftover heat from the Big Bang. By studying it, scientists can see how dark energy has shaped the universe over billions of years. But here's the wild part. We still don't know what dark energy is. Is it a property of space itself, like Einstein's idea of a cosmological constant? Is it some kind of exotic energy field with a fancy name like quintessence? Or is it something we haven't even dreamed of yet? Whatever it is, dark energy is calling the shots, and it's going to shape the future of our galaxy in ways that'll blow your mind. Let's zoom in on what that means for the Milky Way. All right, let's talk about our cosmic home, the Milky Way. It's a gorgeous spiral galaxy, about 100,000 light-years across, packed with stars, planets, and maybe even a few alien neighbors. Who knows? But dark energy doesn't care how pretty our galaxy is. It's got big plans, and they're not exactly warm and fuzzy. To understand what's coming, we need to think billions of years into the future. So, let's hop in our imaginary time machine and see what dark energy has in store for the Milky Way. First, let's set the scene. Right now, the Milky Way is on a collision course with our nearest neighbor, the Andromeda Galaxy. In about 4 billion years, these two galaxies are going to smash into each other. Don't worry, it's not as violent as it sounds. Stars are so far apart that they'll mostly just pass by each other, like dancers in a cosmic waltz. Over time, the two galaxies will merge into a giant elliptical galaxy, sometimes called Milky Way. Cool, right? But here's where dark energy steps in. While gravity is pulling the Milky Way and Andromeda together, dark energy is working on a much larger scale, pushing groups of galaxies apart. Think of it like this. Gravity is like a bunch of friends holding hands, keeping the local group of galaxies, about 54 of them, including the Milky Way and Andromeda, nice and cozy. But dark energy is like a cosmic bouncer, clearing out the rest of the party. Over billions of years, other galaxy groups will get pushed so far away that they'll disappear from our view. Now, let's talk about the really wild stuff, the Big Rip. This is one possible future where dark energy gets way too strong. Imagine dark energy keeps getting stronger and stronger, overwhelming gravity completely. In this scenario, about 22 billion years from now, dark energy could tear apart everything. First, it rips galaxy clusters apart. Then, it tears galaxies like Milky Way into pieces. Eventually, it could even rip apart stars, planets, and, get this, even atoms. Poof! The universe becomes a lonely soup of particles. Okay, I know that sounds terrifying, but don't lose sleep over it. The Big Rip is just one possibility, and it depends on how dark energy behaves in the future. Right now, scientists think dark energy is pretty stable, acting like Einstein's cosmological constant, a steady push. But if it starts acting like a rebellious teenager, growing stronger over time, the Big Rip could be our universe's grand finale. For now, let's just say the Milky Way's future is tied to dark energy's mood swings. But what if the Big Rip doesn't happen? Another possibility is the Big Freeze, where dark energy keeps pushing galaxies apart until the universe is cold, dark, and empty. Stars burn out, black holes evaporate, and the Milky Way, or whatever's left of it, becomes a ghostly relic in a freezing void. Or if dark energy weakens over time, gravity could win, leading to a big crunch, where everything collapses back into a single point. Which one will it be? Nobody knows, but dark energy holds the key. Before we get too lost in these cosmic doomsday scenarios, let's take a step back. Dark energy isn't just about the distant future. It's already shaping the universe's structure, including how galaxies like ours form and evolve. Let's explore that next. If you could zoom out and see the entire universe, it wouldn't look like a random scatter of galaxies. It's more like a cosmic spider web, with galaxies strung together in filaments, walls, and clusters, separated by vast, empty voids. This is called the large-scale structure of the universe, and dark energy is like the artist painting this cosmic masterpiece. In the early universe, right after the Big Bang, everything was hot, dense, and chaotic. Over time, gravity pulled matter together, forming stars, galaxies, and clusters. But dark energy was there from the start, acting like a cosmic referee. It slowed down the formation of these structures by pushing things apart, creating those huge voids, empty spaces that can be hundreds of millions of light years across. Think of voids as the universe's ghost towns, where nothing much is happening because dark energy cleared out the party. Now, here's where it gets interesting. The balance between gravity and dark energy decides how this cosmic web evolves. Gravity wants to clump things together, forming massive galaxy clusters and superclusters. Think of them as the universe's megacities. But dark energy is like a cosmic urban planner, spreading things out and keeping those voids nice and empty. Over billions of years, dark energy's push gets stronger, making it harder for new galaxies to form. The universe is basically saying, no new neighbors allowed. This tug-of-war between gravity and dark energy is why the universe looks the way it does today. And it's why, in the distant future, our Milky Way or Milkometer might end up pretty lonely. As dark energy pushes other galaxy groups farther away, our local group will be like a tiny island in a vast, empty ocean. Imagine looking up at the night sky in 100 billion years and seeing nothing. Just darkness because every other galaxy is too far away to see. But don't despair. The universe is full of surprises, and scientists are working hard to crack the dark energy mystery. Let's talk about how they're doing it and what they've found so far. All right, let's get real for a second. Dark energy is like the universe's ultimate hide-and-seek champion. We can't see it, but we know it's there because of how it messes with everything else. So how do scientists study something they can't even touch? They get creative, using some of the coolest tools in cosmology: supernovae, gravitational lensing, and giant surveys of the sky. Remember those supernovae we talked about earlier? They're not just pretty explosions, they're like cosmic yardsticks. Type E supernovae always explode with the same brightness, so by measuring how dim they look from Earth, scientists can figure out how far away they are. That's how they discovered the universe's acceleration in the first place. And they're still using supernovae to track dark energy's effects over time. Then there's gravitational lensing. This is when light from distant galaxies gets bent by the gravity of massive objects like galaxy clusters. It's like the universe is playing with a funhouse mirror, warping the images of galaxies. By studying these distortions, scientists can map out where matter is and where dark energy is pushing things apart. It's like catching dark energy in the act. And then there are the big players, projects like the Dark Energy Survey and the Euclid mission. The Dark Energy Survey used a massive telescope in Chile to map millions of galaxies, looking for patterns in how they're spread out. Euclid, a space telescope launched by the European Space Agency, is taking it to the next level, scanning the sky to create a 3D map of the universe. These projects are like cosmic detectives, piecing together clues about dark energy's behavior. But here's the exciting part. We're just getting started. Future advancements in particle physics and cosmology could crack the dark energy mystery wide open. Maybe we'll discover it's a new kind of particle, or a weird quirk of quantum mechanics, or something totally out of left field. Whatever it is, every new discovery brings us closer to understanding the fate of our galaxy and the universe itself. So what does all this mean for us? Let's wrap this up and look at the big picture. We've traveled billions of years into the future, zoomed across the cosmic web, and chased the mystery of dark energy. So, what's the verdict for the Milky Way? In the short term, well, short in cosmic terms, it's got a date with Andromeda, forming the grand Milky Way galaxy. But in the long run, dark energy is the one calling the shots. It might isolate our galaxy in a lonely void, tear it apart in a big rip, or freeze it in a cold, dark universe. The truth is, we don't know yet. But that's what makes this so exciting. Dark energy is more than just a force. It's a reminder of how much we still have to learn about the cosmos. Every telescope we point at the sky, every equation we scribble, every experiment we run brings us closer to understanding this invisible puppeteer. And who knows, maybe one day, you, yes, you, will be part of the team that finally cracks the dark energy code. The universe is full of mysteries, and we're just getting started. So what do you think? Is dark energy going to rip our galaxy apart, freeze it, or something else entirely? Drop your thoughts in the comments. I'd love to hear your cosmic predictions. And if you enjoyed this deep dive into the universe, give this video a thumbs up, hit that subscribe button, and ring the bell so you don't miss our next adventure. We've got plenty more mysteries to unravel, from black holes to alien life. Until next time, keep looking up and stay curious.